So we've done the first two. Let's skip down to, we gotta keep track of which ones I'm skipping. Let's skip down to number 5. Okay, we're gonna skip down to number 5 and see if we can figure it out. The log base 4 of 1/16, and I wanna know what that equals. So let's do our loop-de-loo. Here we go. 4 to the x equals 1/16. This is a little tricky. How do we get the 1 over? What do I know about that exponent if this is going to be 1 over? It's got to be negative. Negative what to go from a 4 to a 16? Negative 2. So the answer is negative 2. This is a little, you really got to be thinking, folks. Even though it's Friday, first period, you want to get the heck out of here, you got to be thinking. This is 1 over. The only way to get 1 over is to flip, and you do that if you have a negative exponent. So I know whatever x is, it's going to be negative. Since I'm going from a 4 to a 16, it must be a negative 2. Number 7. Okay, here we go. Let's rethink it. 6 to the x equals the cube root of 6. Okay, now wait a minute.
Wait, is it equal to x or y?
Doesn't matter. Whatever letter you want. M, P, J, whatever letter you want. Now wait, I got a radical here. What kind of exponents give me radicals? Fractions. And if this is a cube root, that has to be a 3 in the bottom. And I didn't change the 6 at all, so would you think that's 1/3? So the answer to the problem is 1/3. The exponent is 1/3. If we've gone from a exponent to a radical, then we know the exponent had to be a fraction. And this number is the denominator of the fraction.
So the numerator would have changed if the 6 was different?
Yes, because the numerator tells me what power. And since that's a 6 and that's a 6, the power was 1. If that had been a 36, the power would be 2. In the top here, 2. All right, how about 8? And again, call it, this can be any letter you want. I'm just trying to figure out what it equals. So what does this say as an exponent? 4 to the x equals 1? 0, exactly. Kids, anything to the 0 power is going to equal 1. So if it's equaling 1, your exponent has to be 0. The only way you're going to get 1 is if your exponent is 0. Okay, 9. What do you think about that one? What's that one equal? 2. 7 to what power is 49? So that would be 2. So the answer to 9 is 2. Very good. I'm skipping around, I know. Stay with me. Number 11. Marita, you need to open your eyes, sweetheart. There is nothing as riveting as logarithms. 3 to the x equals 1/9, right? So what's in my head? In my head is I have 1 over. So I know whatever the exponent is, it has to be negative. 3 to what power would give me a 9? 2. So the answer is negative 2. Slow down your brain. Some of you are saying things like 3. No, 3 to the third would be 27. I needed 2. All right, number 13. 13 is 1. You are exactly right. The log base 6 of 6 says 6 to what power is 6? She said the answer is 1, and she is right. 14. The log base 7 of the square root of 7. Slow your brain down. 7 to what power is the square root of 7? You have gone from an exponent to a radical. The only way that can happen is if your exponent is a fraction, right? Since that's a square root, the denominator of the fraction is a 2. And since the 7 didn't change, the power is still 1. Okay, one more. Skip all the way to 28. The log base 8 of 1. 8 to what power is 1? Remember your loop-de-loop. Gotta be 0. That is exactly right. Now, you're thinking to yourself, Miss Ford, why did you skip all those problems? Well, every one I skipped was a little bit different than this kind of problem, a standard kind of problem. For example, number 4 and 10 and 12 all have something in common. So let's look at 4 and 10 and 12. What is missing when you look at problem 4 and problem 10 and problem 12? What's missing? The little base number, that's right. The little guy right here is missing. What do you, I thought somebody said it. It's 10. This is an understood 10. Whenever you see the symbol LOG with no little number, no base number, that means it's an understood 10. And when I do my problems, I actually write the 10 in. Because as soon as I do that, then it becomes like all the ones we've already done. This would say 10 to what power is 1,000? 10 times 10 times 10, how many times gives me 1,000? 3. So the answer to that problem is 3. What'd you say, Maddie? Okay. Now, how about this one? Here we go. This is number 10. 10 to the x equals 1/10. Guys, it's a fraction. You've gone to 1 over. That means your exponent has to be negative. Since the 10 didn't change, I guess it's just a negative 1. This is 12, problem 12. It's another base 10 problem. What does it say? 10 to the x equals 100?
2.
So x has to be 2. You are exactly right. Good work. Okay, so that takes care of those. What did we make a note of? If we see just LOG, we're going to put in a base 10, right? Okay. Now, what about these ln things? ln EQ. This is problem number 3. What in the world does ln mean?
North.
It's a natural logarithm. This is called a natural logarithm. And it is the symbol for log base E. E is another irrational number like pi. It's called Euler's constant. And it is approximately 2.718. E is a very famous number in math land. It has its own button on the calculator. It's a really, really important number. We're going to be doing some work with E. But right now, we just need to know that every time we see an ln, like in problem number 3, every time I see an ln, it means log base E. So instead of writing ln, I'm going to write log base E. Because then I can do the problem just like I've done all the rest of them. This would say e to the x equals e cubed. Loop-de-loop. E to the x equals e cubed. Well, shoot. If e to the x equals e cubed, x must be 3. So the answer to that problem is 3. I know this is a lot. You've done some of this before. Try to pay attention. Let's look at 6. It's another ln problem. I'm immediately going to think of it as log base E. That works for me. You may not need to do that, but that's what I'm going to do. I'm going to think of it as log base E. Now I'm going to loop-de-loop. E to the x equals 1 over e cubed. Now what is the 1 over? Immediately tell me. Whatever x is, it's going to be negative. 1 over means I went negative. I went from an e to an e cubed. So this must be negative 3. Isn't e to the negative third 1 over e cubed? This is so exciting. I don't know how you can all look so bored. 15, is that the next one? 15. ln e to the 10th.
What?
Log base e of e to the 10th is x. Can you tell me what the answer is? E to the x equals e to the 10th? X is 10. Take a look at problem 3 real quick. What was the answer to problem 3? 3. Now take a look at number 15. What was the answer to number 15? 10. You see something kind of weird going on there? If you have ln e to the 7th, what do you think the answer would be? 7, yeah.
So is it always just whatever?
Always true. Always true. If you have ln e to a power, it's always true. All right, so now I'm on 16. I'm on problem 16. This is log base e. So e to the x equals the cube root of e. Now tell me about x. You're going from an exponent to a radical. So whatever x is, it has to be a fraction. Would you agree? Now, since that's a cube, the denominator has to be 3.
And it's a 1 because the e stays the
And
same.
it's a 1 because the e's not changing, so the answer to the problem is 1/3. That is 16. All right, one more of these, and we're going to do a different kind because there's some more different kinds on here. ln 1 over e. So log base e of 1 over e. E to the x equals 1 over e. Now that's a 1 over. That tells me my exponent's going to be negative, right? And since that's an e and that's just a plain e, I guess it's going to be negative 1. And the answer to the problem then is negative 1. those of you keeping track, did I get everything in the first column?
Yeah.
Okay. So now I'm in the second column and I'm ready for the problems like 18, 19, 22, 23, 24, and 25. All right, so let's start with the 18. This is a property of logarithms. Look at problem 18. Everybody stare at it. Problem 18. The answer to the problem is 10. The answer to the problem is 10. The sixes cancel each other. Exponentials and logarithms are inverses. So the sixes cancel each other, and the answer is 10. Which makes the answer to 19, 2. Which makes the answer to 23, 11. 24, 7. And 25, 7. Because remember, when you see the LOG, the base is 10, right? There's an understood 10 right there. So the answer is 7. What about 22? What's the answer to 22? 4. Because that is e to the log base e of 4. So the answer to 22 is 4. So 22 is 4, 23 is 11, 24 is 7, and 25 is 7. Oh, what about 27? 6. 27 is 6. Because what's ln? Log base e.
So will it always cancel out?
24 is 7. Why would it be 1?
So will it always cancel out?
Yep. Now, that leaves us with number 20, right? We haven't done 20? All right, so let's talk about number 20 for a minute. Let's pretend that the 2's not there. Let's pretend this is all we have. Now you know how to do that problem. You know how to figure that out. This part right here, you know. This says 3 to the x equals 9. So x would equal 2. So this part of the problem you can figure out equals 2. So then you multiply that by 2. So the answer to number 20 is 4. 2 times 2.
So what are you setting that equal to? E? Like
X?
so, like the whole thing's equal to x.
No, just this part right here.
Okay, so then after you multiply it by
After
2,
I get that answer,
yeah.
I times it by the number I covered up.
So then do you equal it to anything, or is it just that
That's
flat
just
number?
the answer.
Okay.
That this equals 4.
Okay.
So 3 log base 2 of 8. I want to know what that equals. So I gotta cover this up. Can't deal with that right now. This part I can figure out. It says 2 to the x equals 8, right? So
3.
what does this equal?
3.
This right here equals 3.
It's 9.
So then I gotta take that 3, this part equals 3, and multiply it by 3, and I get 9. Wait, there's one more. We're gonna finish it. Why are you packing up? It's only 8:47. 26.
The next
The next number.
Is 26. So we have 4 log base 2 of 2.
So it's 1. So it's actually 4.
So I gotta figure out what this is right here, right? So log base 2 of 2, what does that equal? 2 to the x equals 2, that equals 1? So this right here is 1. This, I can work that out, that equals 1. Times 4, so the answer to problem 26 is 4. Now, double check, did we get answers to all those?
Yeah.
Good, all right, so we'll pick up with the next part. We are gonna have a lot of calculator work coming up. So if you have been lackadaisical,